Hello and welcome to the Nova Show. I'm your host, Chris Nova. Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. How's everybody doing today? Welcome in, everyone. Got Noob, good to see you. Long time no see. How's everybody doing? Happy Friday. We actually have real work to do today. We have like almost legit levels of computer work to do. It's very exciting. It's very, very exciting. Very, very exciting. So, how is the internet doing today? How are all of you doing out there? It's been a while, but we're doing C today. I know C, I can participate. I see what you did there. Hey Future, how's it going? Future Highway, we're writing C today. We're not gonna write Rust, I'm sorry. We have to write boring old C. Well, in theory, we don't really know what we're gonna write yet. We have to get into it, but I bet we're gonna end up writing C, if I had to guess. Linux means no says, yeah, a bit rough for me as well as a CET, but definitely gonna go check the recording tomorrow. Hey Matt, Wilcox, hey Miraz. Everyone, it's good to see you. Welcome in, welcome, welcome. Welcome to the show. We're not even gonna fuck around today. We're gonna get right to business. We're gonna get right down to business. We're gonna go to GitHub. We're gonna create a repo. And it will be owned by Chris Nova, and the repository name will be called Nginx Proxy Research Analysis? What do we want to call this? I guess we call it research? We'll call it analysis. How's this? Small research project aimed at understanding. Oh, that's the sound of a scary raid. We got raided by someone. Who did we get raided by? Tiberius is raiding. Julie is here. Hey, all of my C people are here. All the C people showed up today because I'm writing C. What's up, Tiberius? I was just watching you like yesterday or the day before. I can't remember. You were doing a second order SQL injection, and I was hanging out and having a good time watching you work and watching you just casually flex on your burp suite skills like no big deal. It was good to see you. What's up, what's up? Hey Radside, hey Years in Lux. Thanks for the cat emoji. Julie, how's things at your workplace? I'm really proud. I want to show y'all, but I can't. I got my Microsoft badge again. I have a Microsoft badge again. I went and found my old badge. And so I theoretically, I think I could go to Redmond, which would be fun. Anyway, I digress. How's it going, Tiberius? What were you streaming on today? What were you working on? So small research project aimed at understanding failure modes of Nginx and reverse proxy buffering. We'll make it public and we'll make a readme and we will do good old Apache 2. What do we think? Apache 2. The lazy license. Cool. So we're going to be doing some Nginx proxy analysis. So this will be exciting for anybody who's ever curious into like how the internals of Nginx works, or to anyone who ever does any reverse proxy, cough cough, anybody who runs Mastodon, and then also anybody who ever has to do any sort of DDoS or denial of service work, either for or against. Both. It'll be relevant to both. So this is one of those things that a lot of people don't get into every day. It's super specific. We have like a very, very limited set of constraints, which means it's going to make for a fucking fantastic research project. And I get to do it. I'm very excited because I don't get to do research projects that much anymore. So I'll go ahead and do one. So we're gonna get right into it. We have our repo and we're gonna clone it via SSH. And we will see how it goes. Also, one of the things I really want to do, just bear with me here. I want to see if I can't, well, I'm gonna actually mute my microphone. Okay, I actually turned my microphone upside down. So hopefully it still sounds okay to folks out there on your end. And Kevin C. Tofi says DDoS is a great name for a pet. It is. It's a great name for a pet. So we will copy this and we will get to it. We will go to source and we will git clone this. And we will go to Nginx proxy analysis, and then there you go. Okay, so let's just take a few quick notes of what we're going to try to do, and then we will try to get into a container after we've kind of got the initial thing up and going. So we're basically going to build two there's going to be two things that we work on. Oh, and let me do open source. This will be Nginx. Oh, not the whole source. We want to basically do open. Here we go. Nginx proxy analysis. There we go. I need to get a new badge eventually. I'm unrecognizable on the old one. See, this is why I went and got mine, because my old one had like I had like blonde hair in the photograph. I was like, that's not gonna work. So I was down there anyway and swung by and swiped it for a new one. Cool. Okay. So anyway, so we're gonna say the Nginx proxy analysis, and we will basically do this. We'll say questions. Questions to answer. And we might change this, or we'll say, it's really just unknowns. Okay, we'll say, what is the default failure mode of Nginx reverse proxy when a Unix domain socket is in various states? Cool. So actually I'll just put this right here. And so then we will say findings. I guess I can do a thesis and prompt. There we go. Findings. Cool. What other socket conditions? And Nginx failures. Cool. So we will say our thesis is by understanding the conditions on an upstream proxy, we can determine the state of we can predict the state and resource consumption of an Nginx. There you go. I think that's really what we're trying to exercise. Cool. And there we go. Pretty straightforward. We're basically going to just figure out what exact conditions cause an Nginx proxy to fall over, for lack of a better term. So we're going to be building little tiny, like, denial of service micro experiments here locally in C, and then we'll see where it goes from here. So we have a few things we need to do. So first thing we need to do is we want to get Nginx set up, and then I want to build a table. So let me do a markdown table generator. I want to get a table started in my README here, just so I don't have to do this later when my brain is inevitably, you know, in the kernel or wherever else it happens to be. So 3x3 table seems like a decent starting point. And we will say it's going to look like runtime condition. And then we will say Nginx impact, and we'll say the upstream state, and then we'll say and then we want to do a file new file new cool. Let me generate this. So this is where we'll start. I know I did it off screen, but there's one of those like handy dandy little table creators. See how it just it built a nice neat little table for us. And then my IDE will like let me type, and as I type it'll like auto scale my table, so it'll be all nice and neat for us, so I can just punch data in, which is what we want. So we'll run a control, and then we'll put together a few test cases, and we'll just crank out a quick research project. No big deal. Basically, prompt, let me add one more. At what point does Nginx begin to noticeably impact, how do I want to frame this? Basically, when does Nginx fall over, but like using big girl terms? At what point? Thank you for the follow, everyone. Hey, Tawny, how's it going? Tawny says I'm about to lurk. No worries. Building a better word line by line? Yeah, at what point does the resource consumption of Nginx... Oh, we're getting another raid? This is raid number 3? Who's raiding us? Oh, Linux Tips is raiding. Fuck yeah, or heck yeah. Hey, Linux Tips, how's it going? Welcome to the Nova Show, everyone. Today at the Nova Show, we're doing all kinds of stuff. We're writing C, and we are doing some research on the Nginx reverse proxy, specifically the proxy pass directive, which you see everywhere on the internet. And thank you for the follow, everyone. Hey, Whiskey Peters, how's it going? At what point does the resource consumption of Nginx become significant due to upstream traffic conditions? Cool. And then we'll do the control. And then we want to put here in our control, we want to put, we also need a test environment. I'll build a Docker container. We'll do a Docker container later. Let's just start here, and we'll add more as we go. Okay, so we have this. Let's touch proxy, and let's make it a bash script. Starting Nginx reverse proxy. Cool. And so we should just be able to run proxy. There you go, and that worked. And we will want to create another bash script called upstream. And we'll clean that and we'll Emacs upstream. Starting upstream server. Cool. And then we'll want to have, what, do we want to have a make file to run? Do we want to do make test, or do we want to just have like a execute test suite bash script? I'm feeling bashy today. We've been writing a lot of fucking make files lately in my life, haven't we? To test, I'd write a mock server that would misbehave at various points and point Nginx to it while using some HTTP load tool. Pretty much this is exactly what I was thinking, except for my mock server. I was gonna write an actual like Unix domain socket server. And I was, just to get us started, I was gonna have just like a couple of small C programs that are like serve and ignore, right? Like, and it just like responds to all requests, and like maybe we just hard code like an HTTP 200 and just return that or something. I like having it misbehave. I'm just not sure just yet. Like, I don't want to get into the exercise of fuzzing. Like, we're not looking for a vulnerability as much as I just want to just like have a very, very clear understanding of just the basic research here. Like, if we have 24 file descriptors open and they're all in, you know, socket state X, what does Nginx do? What does the memory footprint of Nginx look like? What does the compute footprint of Nginx look like? Misbehaving as in disconnecting in the middle of sending a response. Yeah, we should probably have like a fuzz. Let's do this. We'll make dir cases, and we'll go into cases, and let's copy proxy into here, and we'll just call this we'll call this first one sock listen. Right, and then we can just have a couple of different cases that we run. Does that make sense? Sorry it got flashed by rather quickly, but was there a clean command you ran? Was it a git command? So I have my own little, so here in my local home directory, this is what I have. There we go. So I have Ben, and I also have lib, and I have Etsy, and I have my own temp, and I have my own source here in my home directory. And I kind of build my own little pseudo Linux based off of my home directory. Okay. And then so here in my home, I have all of these little bash scripts I use for different things. This one here called clean is one of my more wonderful, brilliant pieces of work that I've done. And it's just called clean. And this is what I do to like clear up all the junk in my my home and in my downloads and everything. And it doesn't delete it. It moves it to temp. So like I can run clean without really worrying too much about it. And I know if I super fuck up like within like roughly 24 hours, I can like restore whatever. So it's like moving it to the trash can basically. So I just run this command all the live long day, and you can see one of the things it searches for is like all of my Emacs garbage that Emacs likes to leave around. And yeah, so anyway, that's how my clean command works. So we can now go into source Nginx proxy analysis, and we will copy proxy to, we'll call this run cases, sure, and Emacs run cases. Okay, cool. So here's what we do. So basically we will echo, we'll say launching proxy server in the background. And so this will basically just be proxy. Y'all with me so far? Okay. And then we will say, and we want to start the upstream first, don't we? We'll say this. We'll say launching upstream server. And there we go. And we will say upstream. There you go. There we are. Okay. Upstream and proxy. There you go. Cool. So if we run cases, there you go. Launching upstream, launch the proxy, and it'll finish. Cool. So Julie said earlier for our test cases, we kind of want to have different upstreams is what I'm thinking. So let's actually change our code. So we will say launching, and so this will be cases. What did we call the first one? Sock listen. Cool. And so now we have run cases, and so launching upstream sock listen, and then we started reverse Nginx, Cool. And I guess I can use my regular old IDE here. Cool, so there is, we're actually going to get rid of upstream, and sock listen is starting sock listen upstream server. Cool. And then our proxy will be starting Nginx reverse proxy. Beautiful. Okay, so where do we want to start? Do we want to start with the proxy with the Nginx, or do we want to start by writing the server in C? We have two components we have to build. I guess the proxy will be the most generic, so let's get that set up. Cool. Let's make sure. Thank you for the follow, everyone. I really appreciate these follows. Proxy first, says Rage Cuddle. I want everybody like, Proxy, Proxy. Wouldn't that be a cute name for like a border collie? Proxy? I would have a border collie named Proxy. That would be a very cute dog name. Okay, so let's get to it. We're gonna do Nginx first. So first things first, which Nginx? Who knows what types of shenanigans I have gotten into with Nginx on this computer we're running on. So let's uninstall it. Let's just, like, I'm sure I've compiled some stupid shit before, and who knows. So let's make sure that there's no Nginx anywhere on my file system. Rep I installed. Let's just make sure it's all, see, we have Nginx source and we have Nginx beautifier. This is the shit that I do, you guys. And Nginx source. All right, so all of the Nginx related everything should be gone. And so now let's yay sy Nginx. Oh, it's single dash, right? Yeah, okay. So we're running Nginx version this. Will that also remove any, let's go to etc Nginx. That all looks, let's take a look. This looks fine to me. And we're going to be building our own little config anyway, so it doesn't really matter. Nginx is stateless by default, right? That's like the whole thing. It's like Apache. Honestly, more services should be like Nginx. For a beautiful implementation of a fucking piece of software, look no further than Nginx. It's not perfect, but it's pretty darn good. Etsy Nginx for all the artisanal surfing needs. Yeah, Nginx live at the Proxy, says Taniwa. Okay, so we have Nginx version. There we go. And then let's also see... what else do I know? We have like MongoDB, and see, we have something listening on port 80. I think I actually have, hold on, Ox grep Nginx. Yeah, there's a Yoki container still running. You guys remember this the other day? So let's do this. Sudo e Yoki list. There it is. So Yoki kill Nginx sig kill, and then Yoki delete Nginx, and then sudo sudo e Yoki list. Nothing. Okay. And now ps ox grep Nginx. There you go. Okay, so let's document our Nginx. Control. And really, I just want... really all I care about. Is 6.2 out yet? Does anybody know if 6.2 is out yet? Should we upgrade to 6.2 just for fucking, just because we can? We're also gonna need to put a different kernel on Alice, I bet. What are we, Tani, do you know if we're running anything on Alice right now? I don't think we are. I hope not, because I'm about to go do kernel experiments on Alice, which is what I usually do in situations like this. Grip it and rip it. Cool, so let's copy, wait, let's go into source Nginx and let's make dir etsy. And let's copy real Etsy Nginx nginx.conf to Etsy nginx.conf. There we go. So our little proxy here will basically look like this. Nginx. What's our Nginx command to add a config? Oh my god. I always forget that Nginx is single tick. I take back everything I said good about Nginx because it requires one dash for the command line here. I installed Arch with 622 Arch 1-on-1 on my notebook an hour ago. Hi Nova. Hey Malte. Welcome in, Malte. It's good to see you. Malte, are you running on an ARM M1 silicon chip, or what are you running 6.2 on? Tell us everything. You're running a new version of Linux on new hardware. We see this like once in a fucking decade. Come on, tell us something exciting, please. God damn it. What is it? Man, Nginx. How do you do config? Set global configuration. Okay, -c file. That's what we're looking for. Okay. So Nginx -c etsy /nginx.com. I'm just doing it now because you know this is going to because you know this is going to grow out of control. So how do we set it to Man Nginx. What is -c? Use an alternate config file. How do we set it to a relative path? Is it an absolute path? Julie coming in. Has to be an absolute path. Okay, so let's try that. Home source, Nginx proxy, MIME types. Very good. Okay, so it's actually reading our config. Here we go. Where is MIME types? We will comment you out. Bar log Nginx access log. So let's do, how do we define our access log? Isn't it access log /temp /Nginx proxy analysis access.log? Can't use the access log there. Oh, it's right here. Okay, so let's get this scooted over. And this is main. Who knows whatever that is? Unknown log format. Why did main not work there? You have it commented out above. Log format is on top of it. Ah, I see. Thank you, thank you, thank you. Okay, so here, let's actually do this. Let's do this. So we will do I need to add? Okay, so that looks good. And let's also do this, and we will make dir logs, and we will touch logs, git keep, git add, or let's get status. Why is... Okay. And then we will emacs git ignore logs, everything, and we will git add, git ignore, sorry. And then we will get status. There we go. Okay. So we can get rid of those. We'll keep you up there. We'll get rid of MIME types, logs, local, keep alive, gzip, server 80 localhost. And we'll configure the rest of our HTTP stuff in a moment. Okay, let's see if this will actually run. So proxy. Etsy, Nginx logs, error logs failed. Why does... Is there a directive to set like the Nginx like working directory to like my local path? Yeah, the default folder. No. Like it keeps looking for exe Nginx, right? Let's go with... Isn't it the root? Does the Nginx call that root? Let's go see if there's an Nginx root directive. Because it's looking in Etsy. It's looking in Etsy Nginx for config. Unsure if this makes sense to you all. Working directory. Is that what it's called? Nginx working directory. Direct. Core functionality. There, look right here. You were right. Working directory. Cool. Cool. And then can I set that to... Yeah. Can I just do that? Does that work? Is it smart enough to know what that means? Yeah, you can do that. Nginx logs, error log failed. Really, my little C analysis is going to turn into watch Nova fight with Nginx for 4 hours on a Friday night. That's exactly what this stream is about to turn into. LOL, programming in a nutshell, exactly. This says I basically do... I do that? The rest of that's commented out. I guess I could just do this. I feel like it will be solved with the dash logs or something. We tried that already though. Cool. Well, this is good. So we're finally getting the permission denied error. So, and that's just because every hacker who follows me knows that the temp file system is read-write by default. Hint, hint. In this case, isn't Etsy Nginx right? I mean, I guess in theory we could do... Are y'all saying this is what we want to do? No. See, it still appends Etsy Nginx to the front of it because it doesn't resolve the period to local directory, right? You set working directory to period, which is Etsy Nginx. That I've already done that. Right? And my see, it's still here. Etsy Nginx. Y'all are cray. I had so much hopes. Y'all be tripping. Nginx doesn't work. Cancel the internet. I'm going home. And really, like, we're not even going to be serving okay, so open. So we really need to make these things first. So another thing we could do is we could make dir /p var log Nginx proxy analysis. And then we touch var log Nginx proxy analysis /error.log. And then we touch access log, and then we basically can just do this. So this is error log now, and then access log. Starting Nginx reverse proxy. Okay, and then so what's the, you have to do a -G? I think it's man Nginx -G daemon off, I believe. I was looking at the Nginx container the other day. Do you guys remember this? So I think we do -G daemon off like this. You know where we can go and we can see this? It's still in that OCI bundle I have. Var run aura bundles Nginx. And then cat docker entry point.sh. Right? Isn't there a -G somewhere? We'll just go back into source Nginx and we'll just Google it. Okay, Nginx daemon off. I think it's just daemon off. Am I right? Let's see. Sudo e proxy. There it is. Already in use. Pkill f Nginx sudo. They should do it. They should run our Nginx server locally with our config and spit the logs out where we want them. Cool. This is going to be fun to port to a Docker container later. Okay. So Nginx is good. And I guess I could totally do... There you go. There it is. Okay, sweet. Okay, so now let's get this reverse proxy configured. So we want to do an HTML reverse proxy, or not, oh my god, you guys, HTML reverse, an HTTP reverse proxy. Cool. So we'll keep all of our config. We'll keep all of our config like commented out for now. Thank you for the subscription. Or I guess maybe I should say like, sorry for the ads. QQQ. Here's our proxy pass. This is what we want. Let's actually pull up the Nginx reverse proxy. Cool. So we have our server. I kind of want to just get rid of all of this, but I guess we can keep it here. And really, it's not server. It's going to be upstream. And then we need to call it something. We'll call this, the upstream will be our... Can I call it upstream? Hey Jay, how's it going? What are we doing? We're doing some Nginx analysis. And by that I mean Nova's figuring out how to write Nginx config. Cool. So upstream is case upstream. Haha, cool. Cute. And basically what I think we do here I think we basically do server Unix var run Nginx proxy analysis.sock. Okay, so then I think we come down here and we basically are going to do location everything proxy pass HTTP. So remember, we're doing HTTP over a Unix domain socket. That's what we're doing. HTTP over, what did I call it? Case upstream? Yeah. Okay, and then let's see if we get a socket connection error. And then is there an Nginx? How do I set Nginx for both? Oh, actually, let's do this. Sudo e proxy. And then let's tailf var log Nginx everything. Okay, so we have those pulled up if needed. So right away, we've already made a pretty interesting observation, which it should be broken, but it's surprisingly not. Shouldn't the line be server Unix path to socket or something? Did I not do that? Here? Are we talking about line 30? And then I guess, can I try to curl it? And let's see what happens if maybe it just isn't doing anything until you like actually send it traffic. There we go. There we go. All right, cool. So we're getting some good test cases here. I want to make sure I document these. Okay, so we call connect to Unix, no such file or directory. Beautiful. I love doing research. Okay. So runtime condition. We'll say missing socket. What do we want to call this test case? Basically, it's gonna basically just be no socket available. No socket. We'll call it no socket file. Nginx impact 502 bad gateway. The upstream state is no upstream server exists. No socket on the host file system. Cool. I know that's a little hard to grok, so there you go. That's a little more zoomed out there. So we'll call this one no socket file. Cool. So that one was straightforward. What I want to do now is let's get the Nginx stats module configured. Who knows how to configure the Nginx HTTP stub status module? I think we basically just do this. Cool, and let's curl. We got a bad gateway. Cool. And then now how do we localhost 80/stats? Here we go. So this is localhost 80 stats. So I bet if we hammer this and we send a bunch of fucking traffic to it, I bet. There you go. Servers accept handling requests, reading, write, waiting. Okay, so how do we get the Nginx dashboard now? So we had this set up on Pachyderm. Hey Vancouver, how's it going? So we had set up the Nginx dashboard on Pachyderm. Let's see what we can get. There's Nginx mainline. I want the dashboard. So Dominic is the one who set this up originally. And I don't want to use the Grafana one. It was like very gray. There's this thing. So this is Nginx Plus, which we don't have. So there was a different... I know there was like a thing that we had set up. Is it called the status module? I mean, it gave us like all kinds of Nginx HTTP status module. No, this doesn't look like what I'm thinking of. I mean, it was literally this. It was called Nginx Dashboard. I'm wondering if I can find a picture of it. This one. This was it. This is it. This is what I'm thinking of. This is exactly what I'm thinking of. What is this a photograph of? No clue. Thank you, Eigen Taurus. Using Go access? Is it called Go access? Yeah, this is it. See, that little icon right there matches that little icon right there. This is it says Go access. See, this is how you do OSINT. This is how I'm a real hacker. I looked at a picture on Google Images, you guys. The real deal. Okay, so we want Go access. Okay, so let's see if it's... And there you go, look at that. Real-time HTML output. Go access report.html. Maybe we could run Go access as our upstream Unix domain socket. Just kidding. Let's get this thing running. So we need to figure out where var... I guess maybe user share? You just basically pointed out your access logs. Cool. So we will say Arch Linux go access. So we need the content of the HTML file. We need to know where it installs it by default. And we'll copy it into our repo once we find it. Maybe it's on GitHub. Source. Config. We just want the HTML page. This is all the C. So this is the actual go access code. At Etsy go access, goaccess.com. Okay, so it's already installed here. And it's just pretty much straightforward. So this says, so maybe I just do go access var log Nginx. Hey, that worked. So -o report.html. No time was found in your config file. Oh, okay, so I guess we say GUID native log format, Apache Nginx. So let's do this. Let's sudo e copy Etsy go access goaccess.conf to Etsy here. And then chown novix. Let's see. There. So now we should just be able to edit it here. If it does it not, did I not copy it? Oh, that's why. Sorry. Source Nginx. There we go. And where's my chown? There it is. That should do it. There it is. Okay. So now we go here. Nope, not squid. Nginx Apache. There we go. And where's our little runner that we have? Run cases. This is go access. Help. Where's our config? P. Cool. And so that's go access -p. And this is var log nginx proxy analysis access log. Okay, so report.html. No date format was found in your conf file. Bro, I'm pretty sure I just did date format here. Oh, date format now. Okay. No log format was found. Bruh. Oh my god. How many fucking log formats? We'll go with it. We'll go with that one. Why not? Okay. So let's find the Kubernetes Nginx ingress and steal their config. Kubernetes Nginx ingress controller. And let's go find your... Is it going to be a config map? Fucking Helm. I'm so mad at Helm. I gotta talk to my therapist about it. She's just like, Nova, it's not normal for somebody to be this mad at software. I want nginx.conf, bro. Oh, it's in the root? Is there a root fs? Here. There it is. Oh, of course. So then do we just turn our log format off? And so let's echo, let's rm rf var log nginx. And let's dashboard. Okay, and so then let's sudo e proxy. Oh my god. There we go. Okay, so proxy, and then let's give it some traffic. Curl localhost 80. Give it some traffic. And close this. And upstream, good. And let's now run dashboard. Doesn't match specifier. Oh, goodness gracious. I wonder, is there not like a default log format? I guess maybe common log format? Let's try that one. Oh, cool. And then do we have a report? We do have a report.html. So then I think what I do, if I'm not mistaken, I think I do home, Nginx, source, Nginx, proxy, analysis, slash report.html. And there we go. Total requests 8. And let's send some traffic. Boom, 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 boom. Make sure it's all working. Refresh. Do I have to run the dashboard again? Yeah, okay, so that's the first thing that we need to do, is we need to figure out how to run the dashboard like in a loop. Real-time HTML. Okay. So 22, 23, 24, 25, 26, 26. Cool, so that's real time. So let's update our docs. Nice. Dun, dun. We complete with sub status. And HTTP status. Cool. Run the dashboard and open the dashboard in your local browser. And then I guess we want to get rm rf report.html and emacs get ignore report.html and git add and git status. Cool. And git add dashboard. Cool. So we have dashboard, proxy, run cases, and cases sock listen. Okay. Cool. So when we run our run cases, it will basically launch the dashboard. And then there you go. That's probably good for now. Let's try this. So we basically do run cases. What is not, how do you press any key to continue in bash? Is it just read -p? I think it's just read -p. Yeah. There we go. Cool. So that works. And then our proxy here. There we go. Cool. So setting up storage, WebSocket ready, starting sock listen, starting go access dashboard. And we should have a nice, neat little tool. And we're almost done with our little experiment here. Press any key to exit. There we go. What I want to do now is I want to RM, RF, var logs, Nginx, what is it? Proxy. Here in existing logs, and so I should be able to run it, and then I refresh, and no, bro, you are not running. Let's see, where's my error? Launching go access dashboard, WebSocket. Var log. Okay, good. So now we need... Okay, there we go. Oh. There we go. That's the move there. 0. And we spam curl localhost 80. Boom, 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 boom. And we have 7, and then we should be able to restart our experiment and get all new data. Let's see. Refresh. Yay! Okay, cool. I feel like we actually have a little lab environment now, you guys. That was kind of cool, right? I almost know what I'm doing. So there is our lab environment. Now, what I want to do is git ignore. We want to add our git add etc everything -f. Okay, so we have our Nginx conf, we have our access logs. I feel like I was gonna do something. I guess it's fine. Let me save this. Cool. So sudo e run cases. Cool. And then I feel like we can also get, we have referring sites, we have status codes, we have some other things as well. Okay. Oh, Madeline is raiding. What's up, Mads? We love Madeline. We've been getting a lot of raids today. Thank you everybody for your Friday raids. Happy Friday, everyone. I love you all. Madeline, how are you doing? Have I told you today how proud of you I am? Just in general, just how much I see you out there in those streets doing good work. Okay. So we have our... Madeline says, I thought about you all morning. I got lost in the woods on a hike. Oh, good. Getting lost in the woods is a good thing. I often feel that way when I'm writing code. Okay, so we have our Nginx proxy, and we need to capture our readme here. Yeah, shout out to Madeline. If y'all aren't following Madeline, go follow her. She's my jam. That woman is going to be running Silicon Valley in the next 5 years. You mark my words. Wow. And it almost being by 4 hours, and you got rescued by 2 wonderful women and their golden retriever. It sounds like when me and Q go hiking with Barnaby. Nice to meet you. Cheers from Brazil. Thank you, thank you, thank you. Okay, so here is our first runtime condition. No socket file. We got 502 bad gateway. So let's create some more socket conditions. So let's find a example HTTP server. A very simple server in C. Include header. There's a Pico HTTP server. And a make file. Actually, let me do this. Let me run upstairs. We'll take a quick break. When we get back, we're gonna start to write a HTTP server in the C programming language. So I'll be right back. We'll see everybody in just a minute. Thanks for sticking around. Madeline, welcome in. Y'all feel free to entertain yourself while I'm gone. Mods, feel free to share Discords and social medias and all that kind of stuff while I'm away. I'll be right back. I'll see everybody soon. Okay, we're back. We're back. So what we have is, well, one, we can order pizza, which happens in my house like once a fucking year. So I'm actually really excited about this. Potentially getting to order pizza tonight. Okay, so what we want to do, thank you for the follow, everyone. Welcome to the Nova Show. I hope you love it here. We try to just be really chill, cool people, and we try to love and respect each other, and we just want the whole world to be happy. There's a lot of people in this world who have a lot of energy and a lot of hate. And, you know, I don't care who you are or what you believe in. I love you. And I also love pizza. So, I'm just saying, I hope you all love loving your neighbors as much as you love loving pizza. Because here on the Nova Show, we have a very special thing that we do. So if you look behind me, there's this lovely rack. And what you don't see is there's 3 R640s down here. See, there's 1, there's 2, there's 3. They're in a little stack. They sit like right here. On top of them, there's this cavity. There's this void right here in my rack. An extra large pizza box can slide right in there in my rack, and it stays warm from the servers. And I get to hide pizza down here in my office, and my wife doesn't know about it. And I'll just go sneak back and get pizza from back in my rack. And so we're gonna order secret rack pizza tonight and not tell her. And so we'll have, what we do is right here in front of me, there's a secret window, and I crawl out to the front yard and I bring sneaky pizza in and I hide it in my rack, and she doesn't know about it. And it stays warm, right? Like, it'll stay down there, and I'll just eat pizza on my stream and I don't tell anybody. And I just stay locked in my office. This is how you know I'm an actual hacker. I bet it's perfect temp. No, it does. It's super warm. It's super warm. So we found this one. This one looks great. So here is, we have source. Oh, see, this is huge. We have hash tables and makefile. There's that one, and this is Bloom Institute of Technology. So there's this one. This one uses fork. It's very easy to use. And then there's like conmax and listen file descriptors and so on. So one of the things we really want to exercise in our little experiment here is obviously max connections. Serve forever, accept connections. So this is basically listen on a file descriptor. We want it to listen over a Unix domain socket though. Like, I'm happy to write my own, maybe to store PIDs, probably. So making a simple HTTP server in C. Because, I mean, obviously we can do this in Python, we could do this in Rust, and we could do it in Bash with Netcat if we really wanted to. I think really what I'm looking for, though, is I have a lot of things to say about this file, the socket.h file. And I'm just looking for like a lot of the boilerplate that we can just steal to get us started. So socket, address family, sock stream, bind the socket to an address. So this actually looks like a great resource. We're not going to go into it on this stream, but one of the questions I get asked a lot is like, Nova, where do I go learn how to write C and how to do Linux work? Look at this thing. This blog that we're looking at does something most other blogs don't do. It tells you where to find what you need to find, and it teaches you how to use the man pages. This is great. This might actually be my new favorite resource to point people to. So this is how to open and close and read. Let's just scroll to the end and see what this thing looks like. Conclusion, next steps. So here we go. So this is the implementation. So this is webserver.c, ARPA inet, syssocket, define port, buffer size 124. We hard code a response. You guys, this is exactly what we're looking for right here. Unix networking programming from Stevens is the Bible. I have a copy of this. Hold on. Let me go grab it. Sorry, I don't know where my Unix book is. We're still unpacking, but I did find this is another one. This isn't quite the Bible, but it's the next best thing. This is a great one. This is using internet sockets network programming. This is a great book. So I think Tawny is the one who suggested this. In fact, you know what? I'm gonna leave this out because I bet we can even use this book today. I feel like I might have the book. I have the original KNR and the Unix operating system. Cool. Q. We'll close you, and we'll close you, and let's go build our directory source. New file, server.c. We want to make sure we give plenty of credit to the original author here. Thank you for the follow, and we're gonna make some changes to this for our test, but for right now we have this. Okay, so we can go ahead and take that. And then I guess we do need a make file. And do I want to copy the Aura make file? Where, do I have bootkit checked out? We'll grab the bootkit make file. Nginx copy. Thank you for the follow. But once they go to Rust, they never go back. I think the reason we're writing it in C is because we're working so close to Linux right now, and I know other people who I'll be sharing my findings with also write C, so this is just like a quick and easy way. It's just a little more straightforward, I feel like. So we will call our target Upstream. Mm-hmm. Build upstream server. So this is really where most of our research is going to happen. So we will delete everything else, build static install, probe autogen, all of this stuff. Gone. Okay, cool. So we'll make our default is help. There we go. So now we can do make upstream, and there we go. And so now we will go to cd source. And make. And then basically we're gonna copy this make file right here, and then we're gonna have thank you for the follow, everyone. Thank you, thank you. Julie Bean says I gotta go. Have a good one, Nova. Thanks, Julie. Thanks for sticking around. Upstream is building upstream. And basically, we're gonna have one here called compile. Compile local code. Cool. And really all you're gonna do is rmrf target and rmvf star.o. Who knows how many header files we're gonna put, and then here in this one, clean. We can do LL files as well. Here we go, and there is no target here. There we go. Cool. So we have our C file. And let's cat source boopkit boop.c. We'll grab our header here. Bro, oh my god, sometimes I forget how much stupid fucking code I write. Where the main function goes down. Copyright. Let's go check the website. I want to make sure we don't steal anybody's work. And really the only reason I'm putting a copyright on it is to set a good example. So where was our... Here we go. Copyright JP. Okay. So let's compile this and yeah, we'll see how this goes. We might be making different C files. I don't know how our thing is going to make out yet. CD source, no such file or directory. Very good. Okay, so let's set a thing. CC is equal to clang. And we will say clang server C output upstream. World's simplest make target. Am I right? Server.c. Capital CC. Like, why? There we go. Cool. Awesome. Okay, so we have our server.c and let's go to ignore. So we want to report. We want to ignore source/upstream. So if we do make upstream, okay, clang upstream, very good, and echo compile success. Compile okay. Cool. Proxy run cases. And actually, I think we want to do this. What's the idea behind today's project? So basically, we're just trying to do some basic Nginx research. So if you look in the Nginx docs, I looked this morning, there wasn't really any good docs of like how Nginx responds to like Unix domain sockets. Like you see all kinds of docs for TCP because everybody runs TCP, but like you don't really see a lot of like, here's what Nginx will do while it's being configured as a reverse proxy. While it's being configured as a reverse proxy for Unix domain sockets. And so I'm just trying to basically just understand some of like what will Nginx do given various socket conditions. So if the server's online, what will it do? If the server is no longer opening sockets, or if those sockets are all in a given state, what will it do? And so the reason we're writing it in C is so that we can kind of hack into the server, at least that's our hope, and actually like set some interesting like scenarios similar to how we did with BoopKit, where we basically were like, we're going to create a bad environment in C, and then we'll test it and see what Nginx has to say about it, and then we'll, you know, create another bad environment and move on. So the server.c, I bet it's going to end up looking like bad server with upstream in SS closed, bad server with upstream in SS time wait, bad server with, right, like it will have a lot of different checks that we're basically going to perform. And the hope is that we gain some better insight into what Nginx is doing when it's being ran as reverse proxy using a Unix domain socket. No big deal. Okay, love you, bye. Hopefully that answers your question. All right, thank you for explaining. Yeah, of course. Appreciate. Yes. So like we're doing these socket binding and so on and so forth. And so really this like host adder and AFINet, we're gonna change all of this here. We're gonna start to write the actual C here in a second, but this really gets us kind of up and running. And in fact, you know what I could do? We can actually refactor, we'll rename this as basic server TCP.c. Basic server TCP. And we'll call it upstream basic server TCP. Okay, so there's that one. And then for our get ignore, we have these upstreams here. So this will be our basic server TCP. And I think this is AF INET protocol 0. What does int protocol choosing automatically? How do we create a TCP protocol? Let's see. We can man socket, and we want to look for TCP. AF INET sock stream 0. That's fine for right now. So this one is okay, and we can get rid of this. Unreachable code, and I'm fine with that. And let's do this. Make upstream okay. And we will do cases. We have sock listen. And make clean. AF INET is IP. AF Unix is for Unix sockets. No, I know that, Malte. I was not talking about the IP socket. I was talking about how do we specify TCP versus UDP in the socket function. And I think it'll just pick one automatically, which is fine. Yeah, there's AF Unix. There's a few other of the address families we can talk about. But we will get it in a moment. Basically, I just didn't want to lose our, what's it called? Change directory to source and make clean. Our example TCP server, since we know that one already worked. Okay, so let's try this. So make upstream, that should, and then we should be able to do this. Okay, and then we should be able to do make clean and list source, and then there you go. Okay, so let's get all of this added. Git status, git add, git add, git status. There we go. So we have basic server TCP, source makefile, proxy dashboard, and then for our cases. We'll add that in a second. Okay, so let me commit this. Git status, git add, git commit sm, introduce source code for server cases. There's no actual file dev TCP bash, just pattern matches that and that does the network shenanigans when it sees it. It's 100% inside of bash. Sock stream is TCP, says Malte. Got it, Malte, thank you. Sock stream is TCP. Sock stream is connectionless, unreliable datagrams of fixed minimum length. See, I think you can send UDP over sock stream. This is a datagram. I think this is... It's a paragraph in the man page. It doesn't matter. It doesn't matter. We'll create a Unix domain socket here in a second. Okay. So we will say HTML, Nginx, test server. There you go. Server is basic server. What did we call it? TCP. See. Okay, so there is that. I guess we just call it upstream, right? I never knew Bash had a networking API. Of course it does. How else do you think we break into your computers all the time? I am the queen of piping dev TCP to sudo bash. That's like my favorite thing in the world to do. Maybe if we get lucky, if we have enough time, we'll do a hack the box at the end of this, and I'll do a reverse shell, and we can talk about the TCP API in Bash later. Okay, so we'll see what we do. I guess if netcat isn't on the machine, let me put it this way: if netcat ain't on your machine, it's about to be. Okay, so we will say basic server Unix .c. Cool, so let's get our thing. So we'll make upstream and sudo e source upstream Unix. There we go. Cool. So let's write a Unix domain socket server. I'm just reading some example implementation code. Here we go. So basically we create a regular old sock stream. Okay. And then we need to bind it. So here's where TCP really enters the picture, is when we bind the file descriptor to the host adder. And in this case, we are going to bind it to the sock address, and glibc should be smart enough to do the rest. So first things first is we create a socket. Okay. Then we create the address to bind the socket to. In this case, it's going to be our Unix domain socket. So let's go up here and we're going to do pound define sock is equal to, what did we say? This was going to be var run Nginx proxy analysis.sock. I think that's what we set our Nginx config to. Let's go see. I'm just going to copy it just to be sure. Okay. There's that. So we'll get rid of those two. And we'll say, note, this needs to match the upstream. Cool. So then we will do clean up the prior existing socket. So we will unlink our sock. Unlink any pre-existing socket. Ooh. Cool. So here's where we're gonna change. So we will socket adder UN is adder. So let's do this. So we have to initialize the memory and create our socket address really quick. So we will do struct sock adder UN is adder. And actually we can just call this host adder again. And then we'll say int host adder len equal to size of host adder. Okay. So where does UN come from? This has got to be sysun.h. Let's see if we can find it now. There it is. So here we go. So here's the structure describing the address of the address family local, aka AF Unix. This is a Unix domain socket, ladies and germs. So good old un.h, for those of you at home who are wondering. Okay, so we'll create our socket adder. We'll initialize the memory. And let's keep going. So this all goes away. And here we're going to do host adder dot son family is equal to AF Unix. Okay. And then we are going to do a string copy, which looks like it's already imported. So host adder dot the path. Host adder dot sun path. Socket sun and socket Unix. So we're copying onto the sun path the size, which is going to be our host adder length, which I think we have to pass in a pointer here. Wait, no. Hold on. Size T is at the end. So this is going to be our sock, and then this is going to be our size of adder dot sun path -1 semicolon. And then string copy is not imported. Where do we get string copy from? String.h. No. Standard IO? Standard lib? It's gotta be standard lib. Let's see. String copy, where are you at? Who wants to find what header has string copy in it for me? I'll go Google it. It looks like it's in string.h. Is it strings.h? I really thought it would have been. I think the sock define is missing quotes. Ah, there you go. It is in, let's go find it. See, string.h. It was string.h. Benson and Malte were correct. Also, can I just say that if you're watching this stream right now, all 100, however many people are watching the stream, if you're watching the stream, 2 out of the 3 statements are true. Number 1, you're a nerd. Number 2, you're gay. Number 3, you like Diet Coke. 2 out of the 3 of those are true. I'll let you figure out which ones they are. A street copy says electral. 1 and 3. Calm the fuck out. I can confirm 1 and 3. Looks like we have a bunch of nerds who like Diet Coke here. But so for what it's worth, and not to another man, and I have kids, so not to, says Bridgesworth. 1 and 2 says Gannett, can confirm. I also like Diet Dr. Pepper for what it's worth. More than Diet Coke. Like your rack, Chris Nova, very nice. Thank you. I appreciate it. Okay, so size of host adder socket Unix path -1. And then now we bind. Create the client adder. I don't think we need to do client adder. But maybe we might be changing this to sock adder in client adder. Where do we use client adder in this thing? Let's go see. Get client adder. Connection accepted. 4 new connections. I think this just basically does printf, read the request. Okay, yeah, so we just need a client adder to read the request, basically is what it is. So We'll keep client adder. And we bind struct sock adder host adder. So sock fd. Okay. And then we do a noose. Where's my bind statement? Struct sock adder. Pointer. Okay, this can be this expression can be simplified. Length is host adder len equals 0, web server bind. Okay. Listen for somax con. Let's give it a jingle and see what we get. What do y'all think? Buffer size. Variable has incomplete type. Oh, we need our ARPA or inet.h. I think we're gonna have to do some fuckery with our client adder implementation we have in this file since we're moving from TCP to Unix domains, but we'll give it a jingle. So let's run source upstream basic server Unix. There you go. Address family not supported by protocol, so we can't bind here. As expected. So where did we get this web server bind? Address family. Not expected. Protocol. Okay. So struct sock adder. I think that's where you lose me. Sock adder UN. We define struct sock adder host adder, which is a Sun family AF Unix. Host adder len. Where do we calculate host adder len? It's size of host adder. Okay. That looks good. Pocket created successfully. There's client adder. Sock FD is still AFINet, says Multi. Thanks, Multi. Okay, so make upstream and source upstream basic server Unix. Permission denied. The system is down. The system. Listening for active connections. Proxy. Starting Nginx reverse proxy. Who thinks we can curl localhost and it'll actually proxy to our server? We got a bad gateway, ladies and germs. Wow. Looks like nothing, literally nothing happened. That's okay. Successfully bound to address. let's add some more debug here. What do we think? Netstat. No, we're going to use this here. Okay. And let's keep curling. So why is the dashboard not running? Oh, I know why. I know why. Hold on. Run cases. Let's look at our run cases again. Sorry, we gotta now we have to glue everything together with bash. Okay, so run cases. It will run the upstream for us. Which is sock listen. So we're actually gonna re-change this to refactor, rename. We'll call this basic Unix. So that will be that. And so this one will basically be sudo. I guess we're already in inherit sudo. So it'll be source / upstream. Source, / upstream basic server Unix. Okay, so we should be able to do run cases now. Sudo e bang bang. There we go. Okay, so let's see what this did. So we cleared our access log. So let's make sure this should say 0. Okay, and we now, let's see, we launched the upstream server sock listen. So that needs to be tweaked. So this is basic socket Unix now. Basic socket Unix. Okay. And this says launching, starting. Okay. And then we have socket created successfully. Server listening, and there we go. And so now if we do a curl, we get a 502 and we have data. And so now the question is, let's see what var log nginx error log. Connect to Unix var run nginx sock failed, permission denied. And let's tail dash F everything. Okay, so we'll get some space in there, and so let's run our curl. Curl localhost port 80, 500. Servers looks happy, and let's see what we get. Okay, so here's what's going on. So basically, connect to Unix var run nginx proxy analysis sock failed, permission denied. Does this mean that it's not writable? It's not readable? Something's going on here? We have data. Bash is awesome, says Gannon. Yeah. So let's go and inspect the file system. So lsla var run Where's engine? Where's my var run? Okay, so read, write, execute, read, execute, read, execute. So that looks fine to me. Do I need to shown, just hear me out, lol, nice suffix, dot sock? Dot sock equal, I'm confused, multi, what are you LOLing about? Is the equal sign correct? This equal sign tells me it's a symlink. This is like an effect that my terminal does. It adds characters to the end of file names and it changes their color based off of the file type that it is. So I can tell that these are all actual proper Unix domain sockets. Ah, sorry. No, it's okay. If you have ever debugged a Unix domain socket on any of the Hackaderm infrastructure, you would notice that this bash RC likely looks familiar to anybody who has debugged any of our Hackaderm infra. So chown Nginx this. I think Nginx isn't going to open it because it's not owned by Nginx, right? User HTTP. Cool. So run cases and let's curl. Oh my god, that worked. Wow. That was kind of cool. I was not expecting to actually see Nginx proxy test server come back from our C code. We just wrote over a Unix domain socket. I'm sorry, this was a little bit surprising that it just worked. So anyway, we have a connection. Cool. We actually have everything we need to do computer science now. We can write a hypothesis and exercise it and actually perform science. We can perform science. Everybody stand back. Okay, so let's get status, get add, and let's make sure we add everything. So go to cases, get status, get add everything. Go to source, get status, get add everything. And we will do, let's see. And is there anything in logs? No, there's not. So let's actually remove logs. Okay. Git add, git commit sm, introduce Unix domain socket code. There we go. Thank you for the follow free range pizza. Yeah. Okay. So let's run some tests. Well, let's make sure we get everything working, and then we'll actually have like the fun where we like spin up a server, hit it with like a gabajillion requests, kill the server, spin up another one, hit it with like a gabajillion requests, blah 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 blah, like do the whole like thing. And we're not benchmarking hardware or anything like that. We're just understanding what Nginx is doing. That's all we're just trying to like basically perform a set of tests around Nginx, and then we can throw different versions of Nginx at our test suite to see how Nginx performs. That's literally all we're trying to do right now. Okay, so basic server unix.c. Oh, excuse me. So here is where we get to new socket file descriptor except. So let me actually, let's create a bad Unix domain socket. Okay, so here's bad, well, we're gonna rename this later. But basically, in this example, what we're gonna do is we're no longer going to accept new connections. And we'll just let it hang. And we'll go to our make file. And we will do this one now. And so this will be bad server Unix. Okay. And so let's get some test suites going. So run cases. Okay. So let's do initialize the tests. Case happy path. Cool. So we'll start the happy path in the background. Okay. And I guess we want to do the dashboard first. Cool. So the server is now running. And I guess we want to do launch the proxy server in the background. In the background. So we will test. And then we will say this is case happy. Okay. So we will basically do a happy path where we run our basic socket Unix server. And then we're going to want to have another bash script here that we will call traffic. It's going to be very straightforward. And so this is going to be I actually have an example of this right here. It's the one I want. I have a README in my home directory of all of these bash snippets and secrets and stuff that I always forget how to do. Basically just my notes. Okay, cool. So now we have 100. We'll say test request is equal to 1024. Why not? And actually, I'll just hard code it here. Perform a task 1020. Cool. cool. So let's get our curl command nice and happy. So let's do sudo e proxy. And let's run, what is it? Curl silent localhost 80. Why did we get connection accepted? Verbose. Couldn't connect to server. Okay. I think we just want this one. I'm not mistaken. Cool. So we basically, this isn't like a real good DDoS or anything, but this is just like some basic ways of just kind of like hammering the system locally. It's like it's never gonna do anything more than what the system can handle because the same system is what's generating the load. We could do some interesting things with like C groups and, you know, memory limits and stuff, but for right now, let's just start to exercise Nginx and see what happens. Okay, so we will perform 1024 curl requests on port 80, and we'll just add a note. This must match the Nginx conf listen directive. Cool. So basically we will do that, and that's called traffic, and then we go to our run cases, and then we basically say traffic and then we do a read-p, press any key to move to next case. Welcome back, Argentberry. Okay. And we will do this. And then we'll say sad path. And I'll say we'll replace move to next case with continue. Go. And then we have bad socket Unix will come next. So now it's officially the weekend. Fuck yeah, what are you gonna do now that it's the weekend? What you gonna do now that it's the weekend? Bad server Unix. And run cases, press any key to continue. And then we basically kill F9 basic socket Unix. And then we pkill-9 bad socket Unix. Okay. Sudo e run cases. Let's see what we get. Well, we spammed our server, that's for sure. So let's look at these logs again. So we're getting our output here. So we want to let's see. I may or may not actually have an actual DDoS script we can use here. Don't mind me. Connection keep alive. Target nifnly.com. I always target my own stuff. Connection keep alive. No. So what we want to do is we want to cat bin load test remote. Here we go. host load test. There you go. That's the one. Cat lib. I always forget this. Yeah, this is the good one. Okay. Output devnull. We want that for sure. For sure. And here on traffic, we'll add you. And what else do we want to add? User agent, Ubuntu, keep alive. None of that should matter. Well, maybe for Nginx it does, actually. Okay, so let's run sudo run cases. Okay, so let's get rid of this connection accepted and turn off our logs here. So where's our server? So we want to find printf, and we want to just, all we want to do is just oh, sorry, it's not a bash script. Printf. So we will make upstream and sudo run cases. Ah. Basic TCP on line 103. Where did my find and replace? Ah. Okay, so we just did it. So we just sent 1,024 HTTP requests to our happy server. Okay, so let's go check our dashboard. And with this, I should refresh, and this should change to 1024. Okay, and it did. Cool. So far, pretty interesting. Cool. So now, hey, Mim Clear Bams. Also, hello, Chris Nova. Haven't been here in a couple months. Welcome back. Bingo. Okay, so now we're gonna do it with bad data and see what happens. Killed. Case happy. And now we should see 248. No. Okay. So let's make a few changes. Case happy. Case sad. Okay, so let's try this again. So we ran our happy path, and we're back to 1024, and we'll continue. And we ran our sad path, and we're at 1024. So we killed basic socket Unix. And then we started our upstream server. And curl localhost on port 80. And it's hanging. Wow. Well, that would explain it. So I bet if I look in my process tree, we have this is exciting, y'all. We're learning some interesting fucking behavior about Nginx today. I tell you what, with a capital PS aux grep curl. I bet all these curls are fucking hanging. I bet we got 1,024 curl processes hanging on my file system right now. Boom. Yeah, this is very interesting. Who would have fucking known? Full stop. Wow. Wow. That's cool. I love I can do this shit all day, you guys. I'm sorry. I just love learning about how. So all I did in the sad path. I'm sorry. I get excited. It's not even that cool. I just get excited. So basically, I just do nothing. I don't accept a single connection. Okay, so in the happy path, we do all of this we call accept from glibc, and then we basically take the file descriptor and we like get the socket name, and then we read and then we write to it, right? Here we just do nothing. We just do nothing. So here's what I want to see. Fascinating, says Gannett. So here's what I want to see. I want to see how much of this is just sitting in Nginx memory. I want to see how much of this is just sitting in the Nginx memory. So let's do this. Is it going to time out at some point? I didn't add a timeout to my curl request. So the curl could time out, but like, what is Nginx gonna do? Like, I have so many questions now, right? Okay. So let's simmer down. We got nothing to worry about. So let's go to run cases. So I'm actually gonna take a quick break before we move forward. We're gonna want to check the memory of the process before and after we execute the test. So I'll write a bash script after this that's just like git process stats, and basically just like we'll check proc for like how much memory is it using, blah 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 blah. So we'll check that detail and we'll get it into our cases. But first, a small break and a word from our sponsors. We don't have sponsors, but if I did, now would be when I ran them. And we're back. So, thank you for the follow, everyone. Welcome back. Welcome in. Okay, so let's write down our observation here. We have to remember, kids, the difference between fucking around and science is writing it down. Okay, so we have no socket file. We'll say Unix socket no except. Runtime condition. A Unix domain socket server is running, but no longer accepting except new connections. Cool. And Nginx impact is, what was our Nginx impact? It hung, it didn't respond. We'll say, sorry, Nginx clients will hang and wait on server until connection timeout. And the runtime condition, or sorry, the upstream state. I want to look at this. Cool. Clients. So this one is called, what did we call this one? Bad socket Unix. Bad socket Unix. Clients hang on server response until timeout. And then the upstream state is Unix domain socket server is established and but no connections are accepted. That's easy. So let's go back to our run cases one more time. Ooh, excuse me. pkill F9 bad socket Unix. Cool. So let's create like a traffic like, but we'll just call it stats. And we will do kid is equal to 1. I'm not even gonna check to see if it's there. We'll just assume it's there. So here's the real question. Where do we want to look to get the current memory of a process in Linux? Do we want to use sysmon, or do we want to actually let's go look in proc. What do you think? At status. So let's see. So we can look in maps. Here. So these are the current memory maps. We can correlate this with stat_m. So this is init. So now which field do we want to read here? We have size. So this is for every memory map, right? There's got to be a better way of doing this. We want to use sysmon. Benson, are you still around? I feel like you would have an opinion on this. I don't know if I want to use sysmon is the thing. I just don't know if I trust it. There's pmap. Vincent, I always like proc when possible. Malte says maybe have a look at Nginx's open file descriptors. I'm a little distracted. Can you summarize the question? Yeah. So Benson, the question is what is your preferred method of checking the memory footprint of a given process in Linux? And why? No pressure. I guess basically you or my the first person I thought would actually have an opinion. So how do we print this in human? So this looks like it just combines the stuff in proc. So we can do pmap1 rep total. So we could do that. The then behavior of a particular process. I got you. So let's do this. Let me do pmap. Let's do this. So we'll say pmap id rep total. Type cut field delimiter 1. Sorry, field. I always do this wrong. Delimiter space field 5, 6, 7, 8, 9, 10, 2, 3, 4, 5, 11, 12, 13. There it is, 13. Okay. Wow. So we will say mem is equal to this, and then we will echo memory is mem. Cool, memory from proc smap. And let's, where's my run cases? How do you get the PID of a previously launched bash command? I think it's question mark. It's this thing. Okay. Stats. Let's sudo run cases and see what we get. Oh. There. Let me turn the music up. Is that better? So we have WebSocket server ready to accept new client connections. 1024. And then there we go. Finish. I didn't get my memory output. Ah, that's fine. Run cases. C1 is equal to this and we basically do C2 add, and then we do stats C2 stats C2. There we go. Cool. So webs. Yeah, something broke there. Okay. Ppill f run cases. There we go. Okay, so we did web server ready to accept new connections. So we got to launching case happy, starting Nginx, parsing. Okay. Is the background music too loud for folks at home? I'm just wondering how the levels sound to everybody out there. It's good, says Benson. You sure you get the right PID? I think you might get the bash scripts PID. Okay. Levels just fine. Thumbs up on the .mp3. Okay. So basic socket Unix. For some reason, Yeah, this should work. So we say starting upstream server, stopping WebSocket server. So it looks like it's here. So we basically do this, starting upstream server. I don't see starting upstream server in here. I see starting Nginx reverse proxy. I wonder why C1 equals this. This line isn't working. I could try that. Let's see what that does. Maybe the script outputs more than just the PID? Well, I mean, it's not even, it's like not even running the script, right? Like I do this thing here, basic socket Unix, and like we never see this echo, right? Line 2 starting upstream server. I don't see it. We see case happy launching upstream server, which happens right before it, right? But we never see starting. The output is saved to variable C1, says Malte. Good call. And then we see, so I guess let's right, and it's like hanging now. Basic socket Unix is like hanging. Do I do exit 0? So for some reason this is like not, is it because you can't do like double nested like sleeper things? Whatever this operator is called, run in the background operator. I actually don't even know the name of that operator. Does anybody know? That's the bonus question for today. Ampersand, I guess. I mean, I don't know. Right, so then pmap got all messed up, and then now we get starting upstream server, and we have our PID. It's totally in this line. It's here. It's how do you, for some reason this is not executing in nested. Cases. So, you know, we could do this and see what we get. It's whenever we assign the output of this script, it hangs. I mean, what would be another approach here? We could find the PID using PS, maybe, instead? Run cases. So let's see, PS. So let's PS rep OBS. Or let's find a better one, grep bash. What's, I guess, Firebot maybe? No, what's one? I know, Spotify. What about pgrep Spotify? There you go. Head -1. I think that's the move. C1 is equal to pgrep basic socket Unix. It's basic server Unix. Refactor. Basic server Unix. Yes, sweetie. How can I help you? Hey.
I'm gonna do dinner. And then 2, you help get some wood.
7, yes.
You wanna do dinner?
Yes. Okay, so proxy. Okay, so let's get this done. So pgrep basic socket Unix head -1. Okay. So basic server Unix. I want to make sure I get all of my basic server Unix, and then where's my write up here? README. Bad server Unix. Bad server Unix. Bad server Unix. Okay, this is starting to feel a little bit better. Okay, so then we go to our run cases. Basic server Unix. Okay. pkill basic server Unix. Okay. Next. Bad server Unix. There we go. Cool. So hopefully we can actually start to get some interesting memory analysis out of here. Run cases and just map options. So basic server on run cases on line 33. They'll have a typo. I am about ready for a break. Still don't have a PID. So C1. PS aux grep basic. So pgrep isn't getting this, do I? Well, it get that. Pgrep. There it is. Sudo pgrep basic server. There it is. It's because we need to run it as root. Wait, but this whole thing is running as root. .026. This is the bash process. So let's do this. This is an old hack I've done in the past. So basically, we do basic server Unix. We do label equals C1. Somebody rating me? Oh no. That's just the music. Okay, cool. Label equals C2. Let's go to run cases. pgrep C1. And C1. Pgrep C2. Still no PID. Let's do this. we go. Cool. So I'm still not getting anything from pgrep here. So let's pgrep C1 and I'm still not seeing any pgrep output here. There it is. So echo C1 and pgrep Unix. Nothing. Pgrep Nginx. There you go. So we do get processes back. It's probably because we're pgrep basic server Unix instead of C1. No, I added the C1 label to it. We were trying this before. See? Nothing. And then if we just do basic, we get a bunch of stuff for basic, and then we do basic server. We get a bunch of that, but the second we do basic server, still, and then we get nothing. Yes, ops grep basic server. So 358, 353, 537, 328, 428, 288. Something's fucky here. I'm getting tired, you guys. This is like no longer exciting for me. 1179, 1175. How do I do it? A one-time top? And maybe a better one. Is there key mim? Let's just try other approaches here. Or stats. Key map. Is there by F? Let's try another thing really quick. Let's do this. Nginx show memory. Usage, performance, and transactions. Our dashboard doesn't show us, does it? I don't think it does. No, this is only coming from the access logs. Op-B. There it is. Okay, so that's the memory of the basic server, but we want to basically do Nginx. So, God, Nova, I need to go eat food. I'm like trying to get the wrong I spent 30 minutes getting the wrong fucking bed. I need to go take a break. Okay. Sleep 100, pgrep 1. Just get rid of all of this. Just get all. N-1. There it is. Okay. In PID, Nginx PID is equal to pgrep Nginx head-1. Cool. So then we basically do this. Stats. Now let's run it. All right, so sudo e run cases. There we go. Memory, memory. Memory, memory, exit. Okay, so that looked good. Now the question is, why can't we get memory for Nginx? And that's probably because our stats function is no longer working. So let's pgrep init. Cool. So we will basically do PID is equal to 212.343. Oh God. So let's just do this. Mm-hmm. Rep total, and then we will pipe to tr minus the that. That should do it, and this will be a lot more reliable now. Okay, there we go. Cool, so it looks like we have constant memory. At least according to our test, but we can just remove the cut. Cool. So memory total is 12088K, and then we run it again. And let's go to our traffic. Cool. So we sent it, and then I mean, this is pretty close to what we want. We get a memory footprint, and we do this. And so that's the happy path. And then we do it again with the sad path, and this is what we see. So now the question is our Nginx pgrep right, and is it reliable, right? Let's run Proxy, and let's try. So pgrep Nginx. So this is 160, and ps aux grep Nginx. So this is, sorry, 360. And this is the master process, and this is a worker process. And let's just run pgrep. Yeah, I'm not seeing any mutation. The worker holds the connections, says Malte. That is a good call, Malte, and makes sense. So let's do in her run cases. Head 2. The worker holds the connections. So run cases. Nope, we're still seeing flat memory here. And just to be clear, we should be hanging right now. Curl localhost 80. Yeah, right. So it definitely hangs. I'm not seeing... Oh, excuse me. Press any key to continue. I'm guessing Nginx allocates memory, and then it just let's crank up our requests here, shall we? Are we doing tests from a cold Nginx? Yeah, I killed the process and reloaded every time I run a test. Got noob. So let's do run cases, traffic. We'll just add a couple zeros onto the end and see what we get. So maybe you're not consuming the allocation. So honestly, we're probably bounded by standard out right now. This is way too many processes. Here, let's do... how many do we want to do? Let's do 100,000. Cool. So memory was flat, and let's do the same thing with our bad server now. Our bad proxy server. And it still stays flat. So other than instrumenting Nginx or leaning on existing Nginx metrics, we're likely not going to see very much. Huh. We could try it again with... So here's the other thing. Let's go to our Nginx config. So there's worker connections. Let's see what we get here. Ooh, hold on. What happened? Ah, worker connections 2. There we go. Right, so this is kind of what I'm thinking is like Nginx just allocates memory and then manages it. And so unless we actually do some sort of like proper load test, I doubt we're actually going to see any memory changes in Nginx, right? There's also this proxy pass buffer config. Buffers responses from proxied servers. I'm wondering if we like set these to like these two things right here to like very low values. Proxy buffer size must be less than the size of all proxy buffers minus 1 buffer. So we'll say 1 at 2K. And then we got another one, so at least 2 proxy buffers. Proxy buffer size must be less than the size of all proxy buffers. Minus 1. Proxy buffers, proxy busy buffer size. This is busy, buzzy buffers. Proxy busy buffer size. proxy busy buzzer proxy busy buffer size must be equal to or greater than the maximum of the value of proxy buffer size. Oh my god. Must be less than the size of all. Oh my god. I'm just gonna look for an example config here. This is just ridiculous. My brain is, it's too late in the day for me to be. We'll say this is 4K. Proxy buffer size. There we go. And it's still flat memory. And all of these curls are hanging, right? Empty reply from... It looks like we DOSed Nginx finally. Well, that's good. Well, we finally DOSed Nginx. Oh, I am done for the night, you guys. We'll work on this more tomorrow. Let's tail f bar log Nginx proxy. Here we go. Worker connections are not enough. Let's range the logs. And so, too many open files. We'll say in the same memory usage. Let's write up my report. Nginx impact. Clients hang on server response until timeout. And logs. All right, I'm gonna get out of here, you guys. I am wrapping up. Git push origin main. I'll keep it going. Night Chris in chat. Okay, who are we gonna raid? We're gonna raid Zunder. All right, it's Friday night Zunder score, y'all. Y'all know what to do. Who? Show of hands. Who here has raided Zunder before? Who here's been with us when we raid Zunder score? Who knows what to do? Basically, we try to DOS Zunder score's stream. So if you follow him and if you drop emojis in his chat, his OBS will respond. And our attack vector is that if we all raid him at the same time, we can all follow and just smash follow and unfollow, and then also drop emojis in his OBS, and we can effectively DOS his local computer. this is how we tell underscore that we love him. He is a friend of ours, and it's like evil nice. So we're totally gonna go do it. Tani is ready. Tani, I hope you copy those fucking emojis to underscore whenever we go, because he, you know, he's gonna love that. And I'll be there. Underscore is my favorite streamer to watch. He's one of my homies. So we're gonna go raid him and tell him hi and tell him that we love him. And I'm gonna go cook dinner. I love you all. I'll see you next time. Thanks for sticking around, everyone. There'll be more tomorrow. Talk to you later. I'm out of here. We'll see everybody next time.